Satellites are the only observing system that can provide a detailed and up-to-date picture of the global atmospheric state, and DestinE scientists are working on exciting new data fusion techniques to maximize the exploitation of meteorological satellites to better forecast extreme weather events. Our work is focusing on three important elements to improve the exploitation of satellite observations. The first element is spatial resolution. When we look at a satellite image, we can see incredible detail, particularly in rather beautiful cloud structures associated with complex physical processes in the atmosphere, such as convection or hurricanes. But communicating these fine spatial scales in a quantitative way in order to initialize forecast models is highly challenging. In some cases, such as for visible and infrared observations provided by modern geostationary satellites. Even from an altitude of 36,000 kilometers, they are capable of observing features at a finer kilometer scale than the processes captured by our models. The second element is temporal resolution. The geostationary satellites mentioned above are capable of providing an updated picture of the entire Earth disk below them every 10 or 15 minutes. When looking at an animation sequence of these satellite images, one can see some atmospheric features can evolve dramatically on rather short timescales. And in the case of extreme weather events, it is vital to capture rapid intensification for cases with convection or tropical cyclones, and to communicate this to the forecast model. DestinE scientists are working to optimize how frequently satellite observations can be injected into making new initial conditions. In doing this, we seek to investigate and if possibly exploit the fundamental link between the spatial scales of atmospheric phenomena and the timescales on which these phenomena evolve. The third element involves extracting more information from meteorological satellites by exploiting observations made at different wavelengths. Wavelength determines the color of light we see in the visible spectrum. But in the infrared, different wavelengths provide information on different aspects of the atmosphere, such as temperature or humidity at different altitudes and characteristics of the underlying land or ocean surface. Our simulation system builds up a three-dimensional picture of the atmosphere by combining satellite measurements at different wavelengths. And DestinE scientists are seeking to improve the detail of this picture by incorporating finer spectral information. Some of this work is in preparation for a new meteorological satellite, MTGS, to be launched in 2025, which will simultaneously measure thousands of different wavelengths and provide an unprecedented level of three-dimensional detail for observing rapidly evolving weather phenomena. Exploiting the huge wealth of information provided by meteorological satellites is an exciting scientific and technical challenge involving a collaborative team effort across the whole ECMWF. At the same time, viewing the mesmerizing complexity and beauty of our atmosphere as seen by these satellites is very motivating.